Hi everyone, this video is for section 6.3, inverse trig functions. What we're going to go ahead and do with this expression is we want to simplify it down as far as we can. And this one's a little bit different than the previous two videos. So here we have the sign of the inverse cosine of x over 5. Notice that we have a restriction on the variable. We're saying that x can only be between -5 and 5 inclusive. So before we actually go and dive into the full solution of this problem, let's talk about the restriction. Like, why do we have this restriction here? I really don't want you losing sleep over this, okay? So what I'm going to go ahead and do is I'm going to go ahead and do the inverse cosine of -5 over 5. So in other words, I'm substituting that -5 in for x. And then I'm also going to do the inverse cosine of 5 over 5. So inputting that positive 5 in for x. If we evaluate this, we get the inverse cosine of -1, and then we also get the inverse cosine of +1. If we were to evaluate these, we get pi here, and we get 0 here. If you notice, those are the restrictions for the range of your inverse cosine function. So the reason why that specific restriction was set on x was so that we were honoring or respecting the range restriction on that inverse cosine. So that is the reason that you're seeing that inequality followed by there. It's tied to the restriction on the range for your inverse cosine. Cool beans? Okay. So now let's go back to this expression. We want to simplify it down as much as possible because I don't know about you, but looking at the sign of the inverse cosine of x over 5 makes me cry a little bit. I'm really holding back tears, and I'm glad that you guys can't see my face right now because I'm kind of silently ugly crying. So as before, we're going to go ahead and start working with the interior of this expression. Okay. We can use right triangles and therefore the Pythagorean theorem to help me out here. Recall that the inverse cosine of x over 5, it is an angle measure. It's a really ugly way of showing an angle measure, but it is an angle measure. So what I want to do is I'm going to use this to help break apart the pieces for finding my x value, my y value, and my radius. Because from there, I can then use my definition of what I know about, say, for example, in this case, sine, and find out what this expression should look like. Okay, so first off, let's go ahead and put in our right triangle here. Let's put in our mystery theta. I'm choosing to put it down on the bottom. It's just my choice. Okay, so I know that cosines are adjacent over hypotenuse. So adjacent would mean x is here, and hypotenuse would mean 5 is here. Okay, I do not know what y is at this point in time. However, the Pythagorean theorem kind of comes in and reveals it for me. So recall the Pythagorean theorem that I'm going to work with is going to be x squared plus y squared is equal to r squared. I'm going to go ahead and I don't know what x is, I don't know what y is, but I do know that the radius is 5. So we're going to go ahead and evaluate like so. So you're probably saying at this point, well, how is this helping me because I still have two variables? Well, this is true. So the best thing that we can do here is just write y in terms of x. So in other words, we're going to get y by itself. So y will be on the left-hand side of our equation, for example, and then anything with x will be on the right-hand side. And in essence, what I'm doing is I'm describing what y would look like if I wrote it using the x variable instead. So I'm going to subtract x squared from both sides. That's going to give me y squared is equal to 25 minus x squared. And then I'm going to take the square root on both sides. And this gives me y is equal to plus or minus the square root of 25 minus x squared. Resist the urge to take the square root of each term. Remember that you cannot break an expression of 25 minus x squared into terms and just take the square root of 25 and the square root of x squared. That is not how it works. Resist the urge to make that error. Okay. The next thing that we need to do is we need to decide whether we are working with a plus or a minus here. Okay. remember we're looking at our y value. Well, here's where our restriction comes in, okay? If I do a quick unit circle, let's see here. Let's do a quick unit circle here. That's not too bad. We want to note our restriction. So we're working between 0 and pi. So we're just working in the first and second quadrant. We'll notice, what do you notice about the y values here? You should be silently saying, or out loud, I don't care, that they're all positive. So that tells me that my y should be a positive root 25 minus x squared. And at this point, the bottom really does fall out. We're almost done, okay? We've used the inverse cosine information to kind of get the information that we need to know about the specific theta. Now all that we need to do is we need to evaluate, well, what's the sign then of this mystery theta? We know that the sign in this case is going to be y over the radius. Our y value is the positive square root of 25 minus x squared. Our radius is 5. Here's our solution. So that expression of the sine of the inverse cosine of x over 5 is equivalent to saying, well, that's the positive root of 25 minus x squared, all of which is divided by 5. I hope this was helpful.